Hey everyone, this is a really quick explanation about how to do the enzymes and fecal analysis assignment. When you read this introduction, it's going to tell you that you are a scientist and you were collecting enzymes from different environments, but you forgot to label your enzymes before you left. So when you get back to your lab, you have all of this data about pHs and temperatures and how well the enzymes work in each place, but you forgot what the enzymes were, so you labeled them A, B, and C. And it's your job to figure out which enzyme works best in hot temperatures and in acidic pHs and cold temperatures and basic pHs and so on. So when you read this information right here, you collected 3 different enzymes. One of the enzymes was from a group of bacteria that live in the middle of an alkaline hot spring. The word alkaline means a base in pH scale, which remember is 7 to 14 for a pH. Now, hot springs, obviously that means it lives best in hot temperatures. So probably the enzyme that works best in heat between A, B, and C is probably going to be that bacteria's enzymes. Now, we also found 2 enzymes from the digestive tract of a mammal. Now, digestive tracts are typically more acidic or neutral in your intestines, and so that's going to be somewhere between 0 and 7 for pHs. Remember, mammals aren't hot like hot springs, so probably the digestive tract enzymes will be the ones with lower pHs but more neutral temperatures. Now, here's your job. You're going to take these 2 graphs right here. There's a pH graph, there's a temperature graph, and don't forget to title them, but you're going to take all of this data here and you're going to graph it on these 2 graphs. So the pH versus enzyme activity, all of that data is going to go on this graph here. The temperature versus enzyme activity data is going to go here. And you can graph them directly on here. If you want to use your own graph paper, you're more than welcome to, but it has everything set up perfectly. So for the pH, you've got 0 to 14, and you just go by ones. I forget what scale you're supposed to use for temperature, but it should be pretty easy to figure out based on those numbers. And then on the y-axis for both of them, and this one didn't quite show up, this is the percent of enzyme activity, which are all of these numbers right here. So those are going to be the numbers you graph on your y. Now, if you've never graphed multiple lines onto one graph, here's how you would go about this. Let's say that we're doing the pH graph, okay? So you always want to start with one enzyme at a time, and you want to make these different colors. For instance, if I am doing the pH values here, that's always going to be my x-axis. And then the 3 enzymes, their enzyme activity values are each going to be their own y. Now, I'm going to make them with different colors, though, so that I can tell the difference when I make my graphs. Now, you just graph this like normally. Pretend that enzyme B and C don't exist for a second, okay? And all you're going to do is you're going to graph a pH of 1 with an enzyme activity of 0 for enzyme A. And so a pH of 1 would be here, and enzyme activity of 0 would be down here. Now, the next one, we have a pH of 2, but an enzyme activity of 100%, which is, if you go by tens, it's going to be all the way up here. So at a pH of 2, our dot is all the way up there already, okay? And don't forget to connect your dots as you build them. Now, you'll probably get something, you're going to have to finish the plot because mine's going to be a little bit off, but you're probably going to get a certain hill that looks like this. Then, once you've completely graphed and plotted all of the points and connected the dots in one color, then grab a new color, so I'm going to use pink, and grab a new color and start graphing for enzyme B. Ignore the enzyme A and C data, and you're just going to plot the pH versus enzyme B. So we have a pH of 1, but enzyme B also has 0 activity here. It has 0 activity all the way to pH of 4. So that means on our graph, we're going to have 4 pink dots for that. Now, eventually, it's going to start increasing. So notice, at a pH of 5, enzyme B has a 22% activity level. So we find about 22%, which would be, if this is 10% and this is 20%, 22 with a pH of 5 is going to be about here. So then you start connecting your dots like that. And you might end up with a hill that looks like that. And then you're going to do the same thing with your final enzyme. So enzyme C I did in green. And you'll plot your points. You're going to get, I'm not even going to show you what you might get, but you'll get something that goes with that. The temperature graph you do exactly the same way. If you need any help with how to graph these, please ask the sub or ask your neighbors. Quickly on the back side, you're going to take whatever information you graphed and you're going to answer these questions about it. You have to graph first before you can answer these questions. That's the only way to do that. Finally, you're going to do another graph here. This is just a single line graph, though, for the amount of potato tissue and the volume of oxygen gas. This stuff here, if you need help with this graph here, I will help you out when we get back. But you at least need to complete up to here completely for Tuesday when I get back. If you do need help with part 2, I can help you when you get back with that too. But if you don't finish it, you are still going to have to finish that and turn that in for me. So remember to email me if you have questions, ask the sub for help, whatever you need. But this is graphing practice, analyzing how enzymes work. So it's applying what we've learned.